Section 3.2 is the graph of a function. So let's look at the function f of x equals 2x squared minus x minus 1. Is negative 1, 2 on the graph? Well, for that to be true, for that point to be on the graph, f of negative 1 would need to equal 2. We need to see if that is true. So f of negative 1 equals 2 times negative 1 squared minus negative 1 minus 1. Simplifying, we get 2 times 1 plus 1 minus 1, or 2. So, yes, negative 1, 2 is on the graph. B is saying if x equals negative 2, what's f of x? In other words, what is f of negative 2? F of negative 2 equals 2 times negative 2 squared minus negative 2 minus 1, which is equal to 2 times 4 plus 2 minus 1, which is 8 plus 2 minus 1, or 9. So f of negative 2 equals 9. C wants to know if f of x equals negative 1, what is x? So we will replace f of x with negative 1. Negative 1 equals 2x squared minus x minus 1. Let's solve this for x. I'll start by moving everything to the right-hand side because this is quadratic and x squared is positive on the right-hand side, so I will add 1 to both sides. 0 equals 2x squared minus x. Factoring out an x on the right, I get 0 equals x times 2x minus 1. I will set each factor equal to 0. X equals 0, or 2x minus 1 equals 0. So one value of x is x equals 0. The second one, I will add 1 to both sides. 2x equals 1, divide by 2, and x equals 1/2. So if f of x equals negative 1, x equals 0, or 1/2. D is asking for what the domain of f of x is. And since f of x is a quadratic function, its domain is all real numbers. There is no value of x that we cannot graph. E is asking for the x-intercepts. So I will put 0 in for f of x and solve for x. This is a quadratic equation. I will factor the right-hand side into 2x plus 1 times x minus 1. I'll set each factor equal to 0. So 2x plus 1 equals 0, or x minus 1 equals 0. Subtract 1, I get 2x equals negative 1. Divide by 2, x equals negative 1/2. In the second equation, I'll add 1 to both sides, x equals 1. So my two x-intercepts are negative 1/2, 0, and 1, 0. And finally, f wants to know the y-intercepts. So we want to know what f of 0 is. It's equal to 2 times 0 squared minus 0 minus 1, which is negative 1. So my y-intercept is 0, negative 1. Okay, let's look at a problem that we're going to interpret the graph of. Let C be the function whose graph is given below. This graph represents the cost C of using M anytime cell phone minutes in a month for a 5-person family plan. Part A asks for determine C of 0 and interpret. So C of 0 corresponds to this point, where our M value, our number of anytime minutes, is 0. C of 0 is 100. And this is representing the monthly fee that we would be charged whether we used any minutes or not. So even if we don't use any minutes, we're still charged $100. B wants to know what C of 1,000 is. This corresponds to this point. So C of 1,000 is equal to 100. And that means that 1,000 minutes are basically included in the monthly fee because we're not charged anymore for those 1,000 minutes. We're still just charged that basic monthly fee. C wants to know what C of 4,000 is. Corresponds to this point, 4,000 comma 430. So C of 4,000 equals 430. So this represents the monthly charge for 4,000 minutes, which is $430. What is the domain of C? So the domain goes from 0 to 14,000, including both endpoints. That's what we see on that light blue turquoise graph. This implies that there is at most 14,000 anytime minutes. And of course, we're not going to have negative minutes. Then finally, describe the shape of this graph. So we could say that the graph starts off flat or constant and then increases at a constant rate after m equals 1,000.